So now we can wire it back in series again and charge it up and it'll be ready for use. I had a shipment come in today. I ordered this ProWatt sine wave Xantrax 2000 watt inverter the other day, and it finally arrived. It is, as you can see, it is quite a bit larger than my old GoPower 300 watt inverter. So these are both sine wave inverters. With this inverter, I should be able to run basically anything that you would be able to run on a normal household AC socket. Like, they're usually 1,500 watts. So with this inverter, I should be able to run anything that you would normally be able to run on a household AC socket, which is really cool. So that means like table saws, drills, power tools, computers, whatever I want, right? And I'm going to power it all with this 1,200 watt hour battery. And at some point I may add a second battery, but for now, I think it would just kind of be a cool experiment to see like what I can do with this combination, right? So I've spent most of the day upgrading my electrical systems, or planning the electrical system upgrade, right? Before, when I was using that Yeti 400 battery, I was using this 4-gauge wire and like a Anderson power pole 175 amp connector, right? And this stuff is probably overkill for the 400 watt Yeti battery, but this is called 4-aught. You write that 4/0, right? So look at the difference between 4-gauge or 4 AWG versus 4/0. So this stuff is super heavy duty, and it's like tin coated, and it's actually quite flexible. It bends very easily because this is very special MTW wire, or machine wire. And you can see there it is, 4-aught, 4/0 AWG. This stuff should be able to power this inverter at full capacity, because when you, like I've got a 12 volt system. And when you've got a 12 volt system, if you want to put 2,000 watts out or 1,800 watts out, you really need some beefy cables to avoid the voltage drop issues that you would normally have. You could probably run it with like 4 AWG or something, but you'll never be able to get 2,000 watts out of it because your voltage drop will be too high. The cables probably won't melt, but it won't be practical. It won't work, essentially. So big beefy cables. I've got big beefy fuses. This is actually overkill. This is a 400 amp fuse. Now, you know, that cable and this battery are probably capable of delivering 400 amps with no problems. Like, this battery is 1,200 watts, right? And I think it can do 1C continuous. So that's 1,200 watts continuous, which comes out to, I don't know, roughly 100 amps, right? But in bursts, it can do like up to 5C. And 5C is 500 amps at 12 volts. So yeah, so this is actually a little undersized for what the battery is capable of delivering. But what I've decided to do is I've decided to size my system based on the inverter output, because this will be the largest draw on the system. So I'm going to downgrade this fuse to a 250 amp instead of a 400 amp. These are called Class T fuses, and they're very large. So I've been buying all kinds of components today. I bought like bus bars, big 600 amp bus bars with 3/8 mounting posts for ring terminals and such. I bought a bunch more Anderson connectors. Currently I've got one pair of 350 amp Anderson power pole connectors. They use these big, huge, beefy lugs. And I'll be connecting the battery to the rest of the system with one of these, and then I'll also be connecting the inverter to the rest of the system with one of these. So I've got one pair currently, and I ordered another pair for the inverter. And so, you know, that's just basically so that I can like swap out my inverter. If I don't want to lug this big guy around, I can just use my little one. I want to get my battery in here as quickly as possible, and then I can rewire everything later. This slot right here is where my 400 watt Yeti 400 battery went. It was a lead acid battery, and it just snugly fits down in there, and then all of this other space around here was completely unused. So my new LifePO4 battery is 1200 watt hours, and it's roughly the same weight as the old Yeti 400 battery. It's roughly the same weight. But it's a much larger volume. So same weight, more volume. And so what I've done is I've kind of decided on where I want it to sit down here. I took a pencil and I traced around the outside edge of the battery here on 3 sides. I'm going to take a jigsaw and I'm going to cut that out. And then that battery will just snugly fit down in there, and this foam will kind of keep it in place, which is just how the Yeti 400 worked. So let's get out the jigsaw and let's cut this foam. All right, now with any luck, I will be able to reuse this insert if I ever want to reinstall the Yeti 400 battery, which I can't imagine ever wanting to do. Sometimes they say that the best plan is the one that can be changed, so hopefully this works. Let's install this in the case with the battery in there and see how it looks. All right, let's see how it fits. Ha! There we go. At this point, I just need to crimp some cables onto that Anderson connector and attach them to the mounting posts on the battery, and then we'll be able to plug everything back together and see how it works. I had to think about this overnight. So these are the lugs that I bought, and they're designed for like welding cable. This is machine tool wire, so it's kind of the same thing as welding cable, really. My original plan was to put this GBS battery adapter on here, or battery terminal on here, but as you can see, it doesn't fit. It doesn't even come close to fitting. You can see that. Even if I use the one that's a little wider, it hasn't been crimped down as much. You know, you can see that there's just no way that it's ever going to go over the top of this 4/0 cable. My plan has changed. I bought some special lugs for the ends of 4/0 cable that are going to go on the battery, and the special lugs that I bought have no drill pattern. They're just blank on the tongue. I'm going to use that, and I'm going to drill the pattern for the GBS battery onto the tongue. And I can't use these for that because the hole overlaps. This is like a 3/8 inch hole. That's my primary plan, but for a backup plan, I also bought some slightly thinner than 1/4 inch copper plate, and I bought like a foot of it, like one inch wide and like a foot long, and I can use that as a bus bar if I need to. I can drill a regular 3/8 inch hole in it on one end, and on the other end I can drill the GBS battery pattern holes in it. That'll work, but I think that'll stick out a little bit more than a custom lug with a blank pad that's drilled out for the GBS pattern, so I think I'm gonna go with a custom lug probably. In the meantime, I need to get this battery charged up because it's been sitting pretty much drained for like 3 days. I don't want to damage it. So I need to get it charged up, and I think the way I'm going to do that, I'm going to use this 4-gauge wire that I originally had hooked up to my Yeti 400 battery, and I'm going to put these terminals that came with the battery on this wire. So I'm going to crimp these down. I'm going to cut these off. I'm going to strip them a little bit, crimp them down, and I'll just use the wiring as is to bring the battery to voltage using the solar charge controller. And so that'll give me a little bit of opportunity to, you know, see how the battery performs and test it while these parts are coming in, and also get it, you know, charged up so that it doesn't get damaged. At this point, let's go ahead and cut off the ends of these cables here. Mark out how far to strip back. Same thing over here. Okay, so we're ready to crimp those on. I figured I'd try starting out with a 120 die on this TMS hydraulic crimper because the 120 die kind of looks like it fits. All right, that appears to be a bit too big. Let's try the next size down. Next size down from 120 is 70. It appears that is gripping, so I'm gonna turn it sideways, because this is how I actually want the thing to be oriented. I'm gonna try that crimp one more time to kind of get rid of the little ears on the side. Then turn it 90 degrees. And that does seem pretty solid. I like it. Doesn't seem like it's moving at all. Okay, so next I'll do the other one. I know you're probably screaming, "Oh, you forgot the heat shrink." Yeah, there's no heat shrink on here, but this is gonna be a fairly light duty connection. I'm probably only gonna use this for like a couple of weeks, so I'm not too worried about it. All right, so now we gotta fold this other one over. Oh yeah, that works much better. Okay. Turn that one 90 degrees. Okay, and then for the final one, okay, let's see how that looks. It's ugly as hell, but I reckon it's not going anywhere. Cool. Careful I don't touch those contacts together. What's going on, kitty? Okay. Let's install this dude and get it configured for charging. Okay. So there's my battery. Okay, so hopefully you can see this. I've got a negative shunt right here, and I'm not sure if it's going to contact the battery or not. I'm a little concerned about that. It's kind of impossible for me to tell, but I think it's touching. Just because this end is not laying flat, I think that means it's contacting. All right, so this is the underside of my generator. This is the bottom of my switch, which turns off the Midnight Classic charge controller. And then this is the shunt for my Victron power meter. And the shunt is too tall, so it's touching the battery at this point. If I was smart, I would have moved my battery over. I would have, put it over in this section over here so that I wouldn't have to move this, but I'm not smart. So I think what I'm gonna do is I'm gonna try butting the end of this shunt right here, because the this rail right here is what the whole assembly kind of rides on. So I'm just gonna move this over and we'll see if that clears up the problem. I'm gonna loosen this up and I'm gonna try to get this wire to go straight instead of at an angle. That might work. And then for this support here, I'm just going to take the corner off right here so that there's a little bit more room. There we go. Yeah, I think that'll work for a bit. I don't love it. I don't like it even, but I think it'll work. Let's try plugging it in and see what happens here. Turn off the charge controller for now. I don't smell any fires. Okay, I think I better get this thing charging quickly, or it's gonna die, so I'm gonna go do that.